So how do we kind of approach this? So the main basically thing, I think the curriculum kind of mentions a little bit of this, but it's not directly stated. It's basically the idea of this NLP pipeline. And so the idea here is basically you gathering the data, you extract features, and you model. So we're mostly focused today on the text processing part because there's a whole bunch of involved parts like how you would do this. But the main thing is like removing junk. Then we'll move into feature extraction, which I think we'll talk more about next time when we talk about this. And then modeling. So that will be recurrent neural networks, sequence to sequence models and stuff like this. So kind of just overview of like what text processing is. Basically, you just can't feed data unprocessed. And this data really can mean like voice. It could be like, sound, for example. It could be, like an audio clips. It can be text, from like text message back and forth. It can be text of different formats. So think of like an HTML, text from a website. There's going to be a whole bunch of HTML tags in there. It can also be from research groups where they have tags for parts of speech and stuff like that, saying, oh, this is a verb, this is a noun, this is the predicate, those kind of things. So you have to have a way to process that information. So we've seen a little bit, I think, back in module 2, I think, maybe, where we talked about HTML web scraping and stuff like this. That's kind of like similar to here. So you can use things like Beautiful Soup and regex and stuff like this. And so the idea here is that we would first, process this text. And then once we process this text, we would actually look for features that we can use in the model. And so one thing to think of features too is that your feature extraction really depends on the task that you have at hand. Are you looking to do something like machine learning translation? Are you looking more for like, like a document level, saying like, what's the overall feel of this, document, those kind of things. So feature extraction, one common thing is, or one thing you can possibly do is graph representation, which I don't think the curriculum talks too much about. But like the one idea here is like WordNet. Another thing is like hidden Markov models, HMMs. Those can basically build up relationships. So again, the idea of having these words relating to each other and building up that representation from the graph. So that's kind of an interesting one. We'll actually use WordNet in a second to do pre-processing. So it's kind of like how words are connected together. The other way you can think of this is like the document level. It's thinking, we'll talk about bag of words. This really shouldn't have dashes in here. I don't know why I did that. And doc2vec. So the idea here, bag of words and doc2vec is basically taking values from the, the document and converting it into a vectorized form, so numerical representation, so we can actually do something with the model or use the models that we already have that are in numerical form. So some uses, like I said, sentiment analysis, spam detection. So you can think of like things like what's occurring in that word inside that document to say, is it spam or not? So we talked about that with naive Bayes back in like mod 4, I think, something around there. But we talked about naive Bayes, and we can basically say, okay, like, what are some things that are happening in this document, and detecting if it's spam or not, or sentiment analysis, like, is it more positive or negative or whatnot. Okay. Last part, for other features extraction, think about like what you can do, or if you have words and phrases. So these these cases are kind of like text generation. So we talked about GP2 of creating text, creating a chat bot, making sure something's semantically correct, and also like related to what you're trying to achieve, right? You don't want to just say a sentence that is technically correct, but doesn't mean anything. Also machine translation. So think of like Google Translate is a really popular one, basically translating, from one language to another. Understanding this part basically is going to rely on word to word, right? So that's what we have word2vec and glove, which I think the curriculum actually talks about glove and also word2vec. So we'll talk about those two probably next time, but those are other feature things. So these all depend on what you're trying to achieve. If you're trying to do sentiment analysis, you probably don't need to look at the words individually. In the same way, you don't want to look at every single letter in your document. Like the letters themselves aren't the important information. It's probably, something else. In this case, words are the important information. And then maybe for document level, it might be sentences or even paragraph level of information that's being passed forward. Okay. So those are the different kind of basic features that like you can kind of like pull out and stuff like this. The document level, the words and phrases. You can also think of graph representation, which is kind of related to words and phrases, but really it's kind of like about the relationships themselves. Okay, cool. Any questions? Kind of just overall sound pretty good.
So you basically like decide based on what you're looking into which one of these three to employ.
That's right. Mm-hmm. And the idea is you want as low of a resolution as possible, meaning like you would choose a document level over a word level if that's all you need. You wouldn't want to go too deep into something if you don't need it that level. The idea there is because then you have more features, which we saw on machine learning models, means that you have more things to train, more things to consider. Where if you can treat it as a document level, it means you can have it at a more coarse level because you're not looking for very specific parts. Cool. All right. And then just a quick thing I mentioned of like models is that we'll talk about things like if we can get into numerical features, right? We can then use those numerical features for the actual machine learning model. So you can use things like, support vector machines. You can use a neural network. You can use a lot of these things if you already have numerical models, and we already have a lot of tools to optimize for those kind of things. We'll also talk about other models, like for example, recurrent neural networks, LSTMs. Those things can be really interesting because they introduce more dependence. So kind of think of like time series. So kind of like in a word that you have dependence, but what's interesting for especially like sequence to sequence models like recurrent neural networks, you can do things like, what's it called? Bidirectional recurrent neural networks, where you can think of like the future stuff affecting the past, which makes sense in a sentence format, just like that mouse dragging across the desk. You have to know the end of it before you understand what the mouse was to begin. So those are the kind of things that naturally come out for natural language processing. Okay. And so that's kind of like overall like the pipeline, what that looks like. Basically, you gather the data, you process it, you do feature extraction, and then you do the model. So here's an example that I found online that someone had put together. I actually don't know where this exactly came from, but this here basically it's kind of like an example of like a pipeline, an overall pipeline. So here you can see like all their imports. In this case, we'll talk about NLTK, which is a really powerful, I should say powerful, but really common natural language processing library that can do things like pre-processing and everything like that. And you can see here, we can do a lot of things like RE. We've seen this before with regex, regular expressions. That's this part here. We have this NLTK tokenized, NLTK stem, which we'll talk about today. Basically, it's how we process that text. And then you can see some really familiar stuff, the pipeline, confusion matrix, train test split, random forest classifier. And then we also have this feature extraction, which we haven't probably seen before, which is like count vectorizer and TF IDF transformer. I believe TF IDF is mentioned in the curriculum. We'll see if we talk about that next time as we kind of talk about feature extractions and stuff like this. Basically creating those features from the actual data and then actually training it, okay? So you can see here they broke this function. So this is actually a very neat pipeline. So you can see here they actually have their URL regex. So basically this is regex, which is, you can see all these kind of funky letters and everything like this. Basically it's saying pick specific parts. So they have this ready so that they can basically download from a URL and start scraping possibly, or maybe there's an API that can say, oh, gather this information from this URL. In this case, they have like a loading function here. You can see here the read CSV. They're actually getting specific features columns from that data frame, from that CSV. You can see here basically have that X and Y. So in this case, it looks like they're getting the text as the actual value for their X and Y being the category. So they're probably using, in this case, trying to figure out what category this thing belongs into based on the text. Okay. And then you have this tokenize, which is kind of part of the pre-processing steps here. Don't worry if you don't like see all this. We haven't seen some of these things unless you read through section 43 already. But you can see here basically taking a URL regex right here, taking the text. So it's finding those specific maybe URLs within this text right here. They're doing some processing, for example, replacing that URL with a URL placeholder. Oops, sorry. URL placeholder. So the idea here is like maybe there's something that looks like a URL here and it's like, hey, we don't really care about that thing. We don't want to kind of process that in. We're just going to put it that it is a URL. So that's kind of like some extra processing going on here. They take tokens. So tokens we're going to see is basically how we break down like a text, a corpus, not a corpus, but like really a text set and kind of tokenize it where it's like word per word or phrases and stuff like this. Limitizer is a way to basically make sure we have like, we'll see in a second, but basically like, verb conjugation. So if you have like, I went to the store versus I go to the store, those are treated as the same words since they basically mean the same thing. And then you can see you're basically doing some more cleaning and stuff like this until finally they have their clean tokens. So this is part of their pre-processing step. And then right here, it looks like they're actually doing things like where this is where they actually already trained it, but they're kind of making a function to say, okay, we have our predictions of what there should, what the actual values should be, what the actual categories are, what the prediction should be, right? So basically, or what prediction was given from the model, and then actually doing some evaluation on here. So kind of evaluating these parts. And then you can see this main part, which is going to be likely the thing that they actually run, which basically takes in this loading data. So you can see how nice and clean that is right here. They actually do their test string split. They build their pipeline. Here they basically are building their features and then feeding it into their classifier. In this case, it's a random forest. Feeding that in, you can see this pipeline.fit, right? And then making predictions and then actually displaying those results. So in this case, it looks like what labels there were, what the confusion matrix, so where it miscategorized or correctly categorized from the predictions, and then the overall accuracy. So you can kind of see like how this overall can kind of look as kind of like one structure as a pipeline. And so this makes it easy where if you need to load new data in here, you just change this function, override this function, or you have a different tokenized way of processing text, you can just modify this part and your main function really doesn't change that much.
So sorry, so they used a random forest classifier, which means that they changed the language into numbers at some point, right? Where did they do that?
Yeah, so this is actually done right here, is this count vectorizer. So you can think of like this vectorizer is going to be basically taking account of how often this happened, how often these words occur and stuff like this, and it's tokenizing. Tokenizing means like, oh, convert these words into a pre-process, so like go and went are the same word, and then saying how often those words occur. That's creating a vector. And then from this point, it's like, oh, it's a vector now. Then they create this thing called TF-IDF. So this will actually transform, kind of like, you can almost think of it like a special kind of scaling for TF-IDF. Then after that, it's like we have our vector here, we transform that vector. So when it gets fed into the random forest, it'll already be a numerical vector.
So that transforming the vector needs to go along with the count vectorized.
Right, yeah. So this is kind of like, you can think of reading it top down, right?
And could you use like any of the, like if you didn't use a random forest classifier, if you used a different machine learning algorithm, would it work also?
Yeah, so in theory, you could use anything that would take in, as long as whatever this vector output's going to look like, you can use that for other machine learning algorithms and stuff. Whether or not it's going to perform well, it depends on, what your data set looks like and what kind of machine learning algorithm you have. But yeah, you can totally use whatever essentially machine learning, what's it called? Machine learning classifier algorithm you want here. Okay. So you could have something like, I don't know, XGBoost classifier, or a support vector machine classifier, or, a neural network if you want. So yeah.
Okay, thanks.
No problem. Yeah. So again, this kind of makes it a little more flexible. And I think seeing this first, I think hopefully kind of gives you an idea of like what this kind of process might look like on making a pipeline, and like how these different parts kind of connect together. Okay, cool. Right. Any other questions before we move on to some text processing and what that looks like? Pretty good. All right.